Hey everybody, here we go again. Hopefully at this point you've taken the test. Even though I'm going to publish this video on Wednesday, if you haven't taken the test, if it's not after the test on Thursday, I'm going to suggest maybe hold off on this one, unless you really want to get a head start on the next chapter. Um, Also, you should have definitely watched the previous video that details how to add fractions, rational expressions, and stuff like that. Um, but I also feel like I should probably explain why we're doing this now in video form. Um, in case you haven't figured it out, I'm not going to see you again until Wednesday, which possibly is 1 week from today, possibly 1 week from yesterday. Depends. This whole um, video thing is a little bit weird. And I haven't even watched Tenet yet, so I'm not sure exactly how confusing that's going to be. Anyway, um, what we're going to do today is very similar to what we did in the previous video, adding fractions. The only extra step is that so far, everything's been in factored form already, except for there were a couple questions on the assignment, but I'm guessing that most of you are probably okay with that. If you weren't okay with that, well, check out this video. All right, so the problems that we're going to be taking a look at today look similar to what we did previously. The big difference being that some of our denominators are in unfactored form, which just means we've got one extra step to do, and that is factor that denominator, and then we'll approach it pretty much the same as what we did previously. So for this denominator, I see that I've got a 1 as my first coefficient. You'll also see that you're looking at my hand instead of my computer screen, which is going to be nice because I should be able to write a little bit more quickly. I need two numbers I can multiply to get 6, add together to get 5. We'll have x plus 2 and x plus 3. Pro tip on these problems. In order for these to be interesting, one of the factors probably matches up with the other factors in the denominator. In this case, x plus 3 matches up. So, picking up where we were doing problems yesterday, I have the x plus 3 in both of the denominators. So far, so good. I need an x plus 2 in this one also, so I'll multiply by x plus 2 over x plus 2. So now, when I add these together, my denominator will just be x plus 2 times x plus 2, x plus 3. And my numerator will be 2x plus 5 plus 5x times x plus 2. So I'll go ahead and distribute that 5x over the x plus 2 and get 5x squared plus 5x times 2, 10x. And then finally, let's combine like terms. Ooh, sorry about that. That should just be x plus 2 over there. We'll have x plus 2 times x plus 5. And let's see, combining like terms, I've got a 5x squared. It's my only x squared term. 2x plus 10x to get 12x and plus 5. Same as before. If I think that one of these is a factor, I could simplify, but if it is, honestly, it's just going to be a coincidence. Today's more about just adding them together and seeing what we end up with. All right, I'm just going to keep going. If I'm going too fast, you've got a way to pause the video, so I'm not going to worry too much about that. This one, we see that I have two different denominators, neither of which is factored, so I'm going to go ahead and factor. And once again, pro tip, in order for this to be an interesting problem, one of the factors of the denominator on the left is probably going to be the same as one of the factors on the denominator on the right. We'll find out. All right, let's see. Product of negative 3, sum of 2. Let's go with plus 3 minus 1. And then product of negative 8, sum of positive 2. Let's go with plus 4 minus 2. And looks like I was wrong. Looks like I don't have any factors in common. Oh, man. This is going to be a really tough problem. I'm going to have multiply by x plus 3 over x plus 3 and x minus 1 over x minus 1 until I look at the numerators and see, ooh, look at that. I've got an x plus 3 divided by an x plus 3. That cancels out. I've got an x minus 2 over an x minus 2. Sweet, that cancels out. Not a coincidence as the problem writer for these problems. And so now all I really have here is 1 over x plus 4. All I have here is 1 over x minus 1. So I still need a common denominator, but that common denominator is not going to be all that bad. Maybe I'll write this out. Now we're looking at 1 over x minus 1 minus 1 over x plus 4. So I'll multiply the second fraction by x minus 1 over x minus 1. Multiply the first fraction by x plus 4 over x plus 4. So now when I do this, my common denominator of x minus 1 times x plus 4, if you want to FOIL that out, go ahead. I don't. And I've got x plus 4 minus x minus 1. As I mentioned in the previous video, watch out for this. I'm subtracting both of these terms, minus x and minus negative 1. So when I put these together, I'll have x minus x, well, that's 0, and 4 minus negative 1, that gives me a 5. So 5 over x minus 1 times x plus 4. And there's my simplified form. All right, I've got 2 more examples for us to go through, and I'll probably just post the PDF of all 4 of these problems to include with the notes. Next one I want to take a look at looks like this. We'll start by factoring my denominators. Let's see what we come up with. Let's see, product of 6, sum of 5. Let's see, that must be plus 2 and plus 3. At this point, I'm worried because those didn't match up with anything in the numerator. So hopefully they match up over here. Product of 12, sum of 7. Let's go with plus 3 and plus 4. Oh, goodness. That's good. I've got an x plus 3 in both of these denominators. That's a good thing. But I'll still have to multiply by, let's see, I need an x plus 2 to match up with this denominator. So I'll multiply by x plus 2 over x plus 2. They already have an x plus 3. I've got an x plus 4 over here. So I'll multiply by x plus 4 over x plus 4. So now summing everything up here, I've got an x plus 4 times an x minus 4. I'll go ahead and multiply that out. That's a nice difference of squares. Plus, I've got x plus 2 times x minus 2. There's another difference of squares. What an interesting question. And then my denominator, I've got x plus 4 times x plus 3 times x plus 2. I'll just leave that in factored form. And I'm able to put them together because I have the same denominator of x plus 2 times x plus 3 times x plus 4 for both fractions. So I put them together, and now I'll add like terms. X squared plus x squared is 2x squared. Let's see, minus 16 minus 4, we're at minus 20. All divided by x plus 2 times x plus 3 times x plus 4. If I factored out a 2, I would have x squared minus 10, which is not a perfect square. So that one I don't think is going to be factorable to get anything like what we've got here. So there we go. That is my answer. And then one last question with pretty much the same feel. You're hopefully getting an idea. We've seen a couple different ways these problems work out, but they all start the same. Let's factor those denominators. Sum of 2, product of negative 15. We must be looking at minus 3 plus 5. Does that work? 5 minus 3. Yep, looks good. And then product of negative 6, sum of negative 1. We must be looking at minus 3 plus 2. So a couple things happening here. I've got the minus 3, x minus 3 matching up as factors of both denominators. Also, I've got that x plus 5 canceling out with the x plus 5 on that one. So So kind of a combination of the two different things that we saw with the two previous problems. Gosh, it's almost like someone wrote these questions intending to cover all the different possibilities all in combination. Well, anyway, let's take a look at what we've got. I think I'm going to rewrite this just to make sure that we all see what's happening here. X minus 3 times x plus 2 plus, let's see, all I have left over here is 1 over x minus 3 because the x plus 5 canceled out. So I've got x minus 3 as factors already. I've got an x plus 2 in the first one, and I need that in both of them before I can add these together. So I'll multiply by x plus 2 over x plus 2. And now that I've got the same denominator, I can add these together. I've got x minus 8 plus x plus 2 all over x minus 3 times x plus 2. And finally, combine those like terms. X plus x is 2x. Negative 8 plus 2 is negative 6. All divided by x minus 3 times x plus 2. And look at that, 2x minus 6. If I factor that 2 out, I'm left with x minus 3, which does cancel out with that denominator. So this is also taking into account that sometimes when you factor it out, you have a common factor in the numerator and the denominator. So I am going to factor that out so that I can cancel out my x minus 3's, and I'm left with my answer of 2 over x plus 2, which is kind of a nice way to finish. A lot of simplification there. All right. Certainly, if you have any questions, you can get in touch with me through email like you all have been doing this semester. Otherwise, hopefully this goes well. Get some practice with it. The second assignment is due. I believe I've got it set to be due on the day we see each other again. So that'll be on Wednesday, which, yeah, we'll see what the world looks like then. Just imagine, I'm making this on Tuesday night. There's a lot of stuff that could happen between now and when I see you guys again. Let's hope everything is right in the world. Have a great day. Good luck with this stuff. And of course, if there are questions, we'll be able to take a look at those on Wednesday. All right. See you guys. Bye.